In this video, we'll go over an ACT math topic called polynomial factoring. So our first example ACT math problem, this one says, for all x such that x is not equal to 0, which of the following expressions is equivalent to 18x squared plus 24x all divided by 6x? Now they mentioned that x is not equal to 0 because we have 6 times 0 is 0. You'll be dividing by 0, which would be undefined. Okay, so x cannot equal 0. Alright, so once you have that, you want to factor this. At the top you have 18x squared plus 24x. So you want to see what's the common factor between these two. So they each have an x, so I can factor out an x. Look at 18 and 24. 6 can go into both of those, so you have take a 6 out. Once you do that, 6x times what gives you 18x squared. So I need another x to give me x squared, and I need 3. 6 times 3 is 18. And with the 24, 6 times 4 is 24. And I don't need another x because I have the x on the outside. So 6x times 4 is 24x. Alright, then I have the 6x on the bottom. You notice we have 6x on top and 6x on bottom. Those can cancel each other out, leaving you with just a 3x plus 4. Alright, so after that's factored, you can see the answer is C. In this next ACT problem, it says, for all x in the domain of the function x minus 2 divided by x to the third power minus 4x, this function is equivalent to. So again, we need to factor. So we have x minus 2 over x to the third minus 4x. Now if you look on the bottom, they have an x in common, so I can factor out an x there. That's going to leave you x squared, because x times x squared gives you x to the third. And here I need 4. And on the top stays the x minus 2. And we notice what we have here, x squared minus 4. Now you should be able to recognize this right away. This is the difference of two squares, x squared minus 2 squared. Alright, when you have that, you can factor it as x plus 2 times x minus 2. So this is very common on the ACT exam. So on the bottom we have x times x plus 2 times x minus 2, and then x minus 2 on top. And notice it's an x minus 2 on top and bottom, so they cancel out. Leaves you with 1 over x times x plus 2. If we look at the answer choices, none of them are exactly like that, so we need to multiply the bottom out. So x times x is x squared, and x times 2 is 2x. So we have 1 over x squared plus 2x. Alright, so that's going to be answer choice D. Alright, so in this ACT problem it says, for all values of x greater than 4, which of the following expressions is equivalent to x squared plus 6x plus 8 divided by x squared minus 16. Now it says greater than 4 because if we had 4, it'd be on the bottom, 4 squared minus 16 or 16 minus 16 will give you 0, and we can't divide by 0 because that would be undefined. Alright, so we can factor this normally. Take the x squared plus 6x plus 8. Alright, so I need two numbers to multiply to give you 8 and add up to 6. Okay, that's going to be 2 and 4, both positive. 2 times 4 is 8. 2 plus 4 is 6. If I look at the x squared minus 16, again we just have one just like that, so that's really x squared minus 4 squared, difference of two squares. So that's going to be x plus 4 times x minus 4. We put that all together. On top we have x plus 2 times x plus 4 divided by x plus 4 times x minus 4. So we see that x plus 4 on top and bottom, so those cancel out, leaving with just x plus 2 over x minus 4. So we can see that is answer C. So this ACT problem says, which of the following is equal to 2x plus 6 over 3x minus 8x plus 3 over 3x? Now you notice here we have a common denominator, so we just combine the numerators together, subtract them, so 2x plus 6 minus 8x plus 3. That's going to give you 2x plus 6 minus 8x minus 3. Combine like terms. 2 minus 8 is negative 6, so negative 6x. And 6 minus 3 is plus 3. So that gives us negative 6x plus 3 over 3x. Now each of these terms is divisible by 3. The 6, 3, and 3. So what I can do there, that becomes 2, 1, and 1. So that gives me negative 2x plus 1 over x. Okay, so that's going to be answer choice D. This one says, which of the expressions below is a factor of the polynomial 2x to the third power minus 4x squared minus 6x? Alright, so right away I can see that there is a greatest common factor between these three terms. Each has at least one x, so I can take out an x, and then 2, 4, and 6, all divisible by 2, so I can factor out a 2. And that will leave me x to the second here, because 2x times x squared is 2x to the third, and then minus 2x. 2x times negative 2x is the negative 4x squared. And then I need a 3 here. 2x times negative 3 gives me the negative 6x. Alright, so now I have 2x times the quantity x squared minus 2x minus 3. And now I can factor this. I need two numbers that multiply give me negative 3 and add up to negative 2. So I'll get my x's. This is going to be 1 and 3. It has to be negative 3 plus 1 to give me negative 2. And then 1 times negative 3 gives me the negative 3 there. So I have 2x times x plus 1 times x minus 3. So each of these are a factor. X is a factor, x plus 1 is a factor, and x minus 3 is a factor. Okay, so that'll give us choices. The first one, x is a factor, that's true, and x minus 3 is a factor. In this problem it says, which of the following expressions is equivalent to the sum 3 over x squared minus 16 plus 5 over x squared plus 2x minus 8? Now in order to add two fractions, you always need a common denominator. So I want to look at each of these, x squared minus 16. You can see that's the difference of two squares, x squared minus 4 squared. And that factors to x plus 4 times x minus 4. And then we look at x squared minus 2x minus 8. You can factor that. It's going to be x's in the first two spots. I need two numbers that multiply and give me negative 8 and add up to positive 2. Alright, so this could be 4 and 2. And the 4 is going to be positive, the x is going to be negative. Now if we look at this, they have in common x plus 4. Alright, so our common denominator would be x plus 4. And then we need the other two, x minus 2 and x minus 4. Now I'm going to rewrite these two fractions with the common denominator. Now this first one already had x plus 4 and x minus 4. So I need to add the additional to the top, x minus 2. And then the other one that already had x plus 4 and x minus 2. So it needs x minus 4. And then I can distribute the 3. So 3x minus 6. And then 5x minus 20. And then combine these, 3x plus 5x is 8x. Negative 6 minus 20 is negative 26. And all over x plus 4 times x minus 4 times x minus 2. And that's going to give us answer E. Alright, so I want to revisit this question. Now we've been solving these by actually factoring them, but there is another way you can solve these. And this is one method, one strategy you can use is replacing the x with some value. So this said for all values greater than 4, so let's just make x 5. And I'm going to plug that into the original expression here. So 5 squared minus or plus 6 times 5 plus 8 over 5 squared minus 16. Now you put that in the calculator, get 63 over 9, which comes out to be 7. Now the equivalent expression will give you the same value. So if I look at A, 5 plus 8 over negative 16, so that's not going to give you 7. 5 plus 4 over 5 minus 4, that's going to be 9 over 1, or 9, so that doesn't work. C, 5 plus 2 over 5 minus 4, that gives us a 7 over 1, or 7. Alright, I'll just try the rest. 5 plus 2 or 5 plus 4, 7 over 9, that doesn't work. And then 5 minus 2 over 5 plus 4, which is 3 over 9, or 1/3. So here, it worked out in the right answer. So, whatever method is faster for you. So if you plug in the value for x and see which answer choice gives you the same value, or you can factor it out and come up with the expression. Alright, so try both methods and see which one's faster for you.